assume that you are having a chemical reaction, okay, and you would like to know what is the maximal temperature that you can get out of this chemical reaction, okay? So meaning like in practice, let's say in a Brayton cycle, what is the maximal temperature that you can get thanks to your combustion process in your combustion chamber? This is extremely important information because one, this will allow you to design your combustion chamber and to make sure that the material properties that you are selecting can support this temperature, high temperature. From another side is that we remember that Carnot told us that the maximal efficiency of a Carnot cycle is equal to 1 minus TL over TH, and TH is our maximal temperature. So knowing the maximal temperature that we can get is essential. Now, how can we do this when we have a chemical reaction? For this, we would need to calculate what we call adiabatic flame temperature. So you see this is adiabatic, okay? And there is a reason why it's adiabatic. Because if you consider a chemical reaction, okay, and you assume that the process is adiabatic, this means that all the energy generated thanks to your chemical reaction, nothing is leaving your system, and all the energy is used to increase the enthalpy. Now, since we are mostly dealing with mixture of gases, for example, in the products, and we assume them typically as ideal gases, so therefore the enthalpy is only a function of temperature. This means that all the energy goes to an increase in enthalpy, meaning an increase in temperature. Now, when we look at our first law of thermodynamics, under the simplified form where we neglect the variation in kinetic energy, potential energy, and there is no work, we have work out plus the summation over all our product of number of moles of the products cross the enthalpy of formation plus the actual enthalpy minus the reference enthalpy. This is equal to what? Is equal to what we have the reactants, the summation over all our reactants of number of moles of our reactants cross the enthalpy of formation of each reactant plus the actual enthalpy minus the reference enthalpy, okay? But you see, we said that it's adiabatic, so therefore this term will be equal to 0. And this leads to get actually the adiabatic flame temperature, we simply have to calculate the summation over all the products NP, enthalpy of formation, plus actual enthalpy minus our reference enthalpy will be exactly equal to the summation over all our reactants, number of moles of each reactant cross the enthalpy of formation plus the actual enthalpy minus the reference enthalpy, right? So basically we have to find the temperature. What is the temperature that will satisfy, if you want, this equation, or this term minus this one is equal to 0. But here we have a problem. The problem that we are having is that we don't know the temperature because this is exactly what we are looking for.